addition of vectors. We will explain this topic using the example. Before explaining this topic, we will explain some properties of vector addition. Property 1. For any two vectors a and b, a plus b is equal to b plus a. This is called commutative property of addition. And property 2, for any three vectors a, b and c, a plus b plus c is equal to a plus b plus c. This is called associative property. For proper explanation of addition of vectors, taking example 8, find the unit vector in the direction of the sum of the vectors a and vector b. First we have to find out the addition of these two vectors a and b. Addition of two vectors. Given that vector a is equal to this and vector b is equal to this, then a plus b is equal to, if we will denote this by c, then a plus b is equal to 2i plus 2i 4i plus 2j plus 1j 3j minus 5k plus 3k is equal to minus 2k. Then a plus b is equal to 4i plus 3j minus 2k. This is the addition process for vectors. And in this question we have to find out the unit vector in the direction of sum of this vector. Already we have find out the addition of two vectors a plus b. Now we have to find out unit vector of vector c. Unit for calculating unit vector, first we have to find out magnitude of vector c. Magnitude of vector c is equal to 4 under root of 4 square plus 3 square plus minus 2 square. And if we calculate it, then we find out the magnitude of vector c is equal to under root of 29. Then we can find out the required unit vector cap of c. Unit vector cap of c is equal to 1 upon magnitude of c into vector c. By putting the value, we get the required unit vector is equal to 4 upon under root of 29i plus 3 upon under root of 29j minus 2 upon under root of 29k. Thus we have explained both terms, addition of vectors and unit vector, also by this example. Next we will explain some terminology like direction ratio and direction cosines. We will explain these things by example 9. Write the direction ratios of the vector a and hence calculate its direction cosines. First we will explain what is direction ratios. If vector r is equal to I plus j minus 2k, then direction ratios are 1, 1 and minus 2. We will denote it by ABC. Direction ratios are ABC. Here for this vector direction ratios are 1, 1 and minus 2. and direction cosines. Direction cosines, we denote direction cosines by L, M and N. Direction cosine L is equal to A upon magnitude of R, vector R. For finding out the direction cosines, we have to find out magnitude of vector R. Magnitude of vector R is equal to under root of 6. Then direction cosines L is equal to A upon magnitude of R. Value of A is equal to 1 upon, and value of magnitude of R is equal to under root of 6. Then L is equal to 1 upon root 6. M is equal to B upon magnitude of R, that is 1 upon under root of 6. Similarly, N is equal to C upon magnitude of R, and here C is equal to minus 2, then minus 2 upon root 6. Thus, direction cosines are 1 upon root 6, 1 upon root 6 and minus 2 upon root 6 for this given vector R. Next, vector joining 2 points. Vector joining 2 points, and next topic is section formula. These two topics we will explain using the example 16. Vector joining 2 points. Example 10, find the vector joining the points this and this directed from P to Q. If point P and Q, 2 points given that P 2, 3 and 0, and Q minus 1, minus 2 and minus 4. Then the vector is to be directed from P to Q. Clearly P is the initial point. P is initial point and Q is the terminal point, P to Q. So the required vector joining P and Q is the vector PQ given by PQ, vector PQ. Then vector PQ will be minus 1, minus 2 I plus minus 2, minus 3 J plus minus 4 and minus 0, minus 4, minus 0 K. If we simplify it, then we find out PQ, vector PQ is equal to minus 3I, minus 5J and minus 4K. This is the example for joining of the points. Okay, next topics will be covered in next content. Thank you.